So a direct variation, it's literally just a line on a graph. This will be a line. And it's in this format, y equals k times x, a direct relationship, nothing added or subtracted to the side. There's different ways this could look, and we could just literally have something like y equals 3x, or we could have, I don't know, y equals negative 2 times x, or actually, here's a weird one. Maybe we could have y equals 1/2 x or something like that. It's just some number times x, and I will show you just really quickly. That one I just wrote, that 1/2 x, an equivalent way to write this, which is kind of tricky, would be to write that as x over 2. That's a direct relationship. The variable is going to be right next to a number, or it might be on top of a number. That 1/2 x is the same thing as x over 2, just as a little example. And then what the k in that lovely formula represents what we call the constant of variation. So I constantly multiply the x value by this to get the y value. It's the same every time. The constant of variation k, let me write this to the side here. So if I took y equals k times x and I solved that, or I got k by itself on one side. If I took this and got k by itself on one side, what would that look like, or what would you do? If I just had y equals k times x, if I told you let's get k by itself, what would you do? Divide by x. Okay, so another kind of, I don't want to say formula, but another important thing to know here, if you have a direct variation, the k value will always be y divided by x. So that's another important. Here's the actual relationship, y equals k times x, but if you need to find the constant of variation, you can take y divided by x to do that. Okay, now, on a graph, the k value is just going to be the slope. Now, the thing is, it has to just be some number times x. So if you have a graph, it has to go through 0, 0. Has to go through 0, 0. If it's in this format, some number times x, we don't have like a +2 or something like that. So you don't have a y-intercept other than 0. It has to go through 0, 0. So if it asks you to look at a graph and say, hey, is this a direct variation or not? If it doesn't go through the origin, like this one in the middle, I immediately know, like that's not a direct variation because it doesn't go through the origin. These other two do go through the origin. So I know these both are. If you want to figure out your k value, it should just be the slope of the line. So if you're trying to figure out a slope, easiest thing I can tell you to do is grab 2 points that go right through a corner and just do rise over run. Go from left to right. If you have to go up, you're at positive, so I'm going up 1 over 2. So this would be y equals 1/2 x. The k value would be 1/2. If you don't go through the origin, it's not a direct variation because you'd have something added to the side. It wouldn't just be k times x. Like this one would be, what is this one? Going up 2 over, so this would be y equals, let's see, 2x plus 1. But because of the plus 1 part, that destroys the direct variation because it's not just some number times x. So that's not going to be a direct variation there. This one, though, this one is, can anybody tell me what the slope of that third picture is? -3. This should just be -3x if it asks you for the k value. It's just the slope if you have a line. So you're just going down 3 over 1. If you grab 2 points that go right through a corner, just do like a little slope triangle there. Just -3x. Should not have a y-intercept if you're doing a direct variation. Okay, so that's from a graph. If you have a table, which is what I have next, remember that little tiny equation I gave you at the top? So this has to be in this format, y equals k times x. The k value would just be the y-coordinate divided by the x-coordinate. But if you don't know if it's a direct variation, you would have to check that. So what I would just tell you to do, just take each one of the coordinates in the table. So like I have the 0.24. The y-coordinate, you're going to divide it. If it's direct, you're going to divide. That's how I remember that. If I divide the y-coordinate by the x-coordinate, if it's the same for every single set of points they give me in the table, then you can make the conclusion that it's a direct variation. So like if I do, 4 divided by 2, that's 2. 8 divided by 4, that's 2. 36 divided by 18, that's 2. If they're all the same, they have to all be the same, then that is your k value. So the equation there would be y equals 2x. That's your direct relationship there. If they asked you for it, the constant of variation would be 2. So you're just going to check that. It'd be the same. It has to be the same every time. If one of them doesn't give you the same bless you fraction, then you're done. So like if I do this one, it's the y coordinate divided by the x coordinate. So like 9 over 27, 10 over 30, 20 over 60. Are all those the same fraction? Do these all reduce to the same thing? 1/3, right? All those are 1/3. As long as they're all the same, then for sure this is a direct variation. If it's me, I'm probably going to write it like this, but just to show you this, you can write it in that format as well, x over 3. The k value is going to be the 1/3. Okay, now I got one more to check. So 66 divided by 11, right, that's 6. 40 divided by 8, that's 5. I could stop right then and there because as long as one of them doesn't match the others, you're done. 42 divided by 7 is 6. But this guy, that's not the same as the other two. So this is not going to be a direct relationship. So I wouldn't write an equation. I wouldn't state a k value. They all have to be the same for the y divided by the x. If they're not, then you're done. So we got a graph, we got a table. All right, now, from an equation, and you might be able to tell this really quickly, it says determine whether the function is a direct variation. So if it's a direct variation, I have to be able to write it in this format, k times x. So easiest thing I can tell you to do if you're trying to figure this out, let's just get y by itself on one side. So I'd divide by 4 there real quick. So kind of two ways. I could write it like this, or I could I would probably kind of pull that 5/4 to the side if it was me. Would you guys tell me that's a direct relationship for that first equation? Is it just some number times x? Yeah, so we're good. All right, so yes, if it asks you the k value here is 5 over 4. Now, I look at this and I immediately know this is not. Does anybody know why? It has a plus. You can't have like an extra. Like I could go through here, right, and divide everybody by 3, and this ends up being like 3x plus 2 or whatever, which is the nice equation of a line. But this plus 2, or even just looking at it before I even started, I know it's not going to be direct because it just literally has to be y equals some number times x. So that one's not a direct relationship. Does anybody have a question? Okay. Now, these are a little tricky. You might want a calculator for a couple of these questions down here at the bottom. So these will be kind of like 2 questions in one. So it'll say the ordered pair is from a direct variation. Find the constant of variation, then write the equation of direct variation. Find the missing value. Okay, so these are like 2 separate questions. So my first question is going to be to write the direct variation. So here's my point. The x value is 4, the y value is 20. Literally all you have to do, real quick, the k value should just be the y coordinate divided by the x coordinate. Or if you want to, you can literally plug it in. Do y, which is 20, equals k times x, which is 4. If I just divide both sides by 4 there real quick, the k value would be 5. So the general equation right there would be y equals 5x. That would be the direct variation that goes through that point. If you just need the k value, though, you can just take the y coordinate divided by the x like we did with the table. Or, like I said, you can full on plug it into that y equals kx, put the y coordinate in for y, x coordinate in for x. You end up doing the same algebra. Now, they always, in these scenarios, will then have like a secondary question for these problems. Find y if x is 6. So if my general equation is y equals 5x, find y when x is 6. You literally just plug in 6 for x is all you're going to do there. So then my second answer to that question would be y equals 30. But these problems a lot of times will have kind of like two parts to the question. Okay, so let me do one more. If this is in the format y equals kx, I'm going to use that point to find k, the constant of variation. So I can put the y coordinate in for y, solve for k here, times 3. I'm going to divide both sides by 3. Okay, if you divide, I should have left myself some more room here. You can do this on your calculator if you want to. If you take 1/3 and you divide that by 3, it's the same as multiplying by the reciprocal. So I'm going to just kind of write this over 1 real quick. So 1/3, I'm going to keep that, change that to multiplication, and divide by 3 would be the same thing as multiplying by 1/3. So that's where I'm going to get 1/9 here as my k value. A little bit tricky, and feel free to use your calculator if you want to. Just want to show you where that came from. So this would be y equals 1/9 times x. Okay, then it says, again, they always have like a secondary question. So after you write down your formula, it says find x when y is -4. So I would do -4 equals 1/9 times x. How would you solve that for x? Like, what would you do to get the 1/9 away from it? Multiply by 9. Just multiply by the reciprocal, easiest way to do it. 1/9 and 9 are reciprocal, so they'll cancel each other out. This would just give you -36 there for your x. Is anybody having a question? I'll give you guys these formulas, of course, on all the tests and quizzes, like the y equals kx that we've been using. Okay, so all this on the front side is a direct relationship. And now we are going to get into an inverse relationship on the back. All right, so these are actually kind of, yeah. Yeah, you is it back there right now?
Yeah. How do you know if it's charging? Is it just like
Does it have a, if it doesn't have a light on it, it should be okay. I'll look at it in a second. I'll just go through this real quick. All right. If it has, some of them have lights and some of them don't. If it doesn't have a light, it should be okay as long as you put it in the tray. Okay, now inverse variation. So this looks a little bit different. So this is k over x. All right, and again, k is just going to be a number. And let me give you just a couple different ways that this could look. So you could just have something basic, like maybe we have 5 over x, and I'm not on the screen fired. Okay, scooch this down. All right, so we could have something like that. You could, as long as the variable's in the bottom, you could have something like, I'm just going to make something up, like let's say I had 2 over 3x. You could have something like that too. In this little example, k would be 5. In this little example, k would be 2/3. But as long as your x is in the bottom of the fraction, and it can't have a number with it, as long as it's in the bottom, that's going to be what we call an inverse relationship. Now, the constant of variation there is going to, again, be, this is just k. So let me give you a little example here. If I told you we were going to take that y equals k over x and solve that for k, what would you do to get k by itself here? Multiply, right? Okay. So this is a little different than what we just did. You'd multiply both sides by x. So in this situation, your constant of variation is x times y. And we're not going to do any graphs with these today. We're going to spend like 2 full days working on graphs of these because they're very different looking than any kind of a graph you've done before. And they don't necessarily go through a specific point, like a direct variation has to go through 0, 0. When you guys actually see the shapes of these do not go through the origin or a specific point. But if you have an inverse relationship, the x-coordinate times the y-coordinate has to be the same for every point. So if you want to check these guys to see if you have an inverse relationship, you would just take the x-coordinate times the y-coordinate and just test to see if that's the same. If it's the same value for every single one, like these guys are all going to be equal to 6, then this is an inverse relationship. This is going to be, as long as they're all the same, that's your k value. And you just write the equation here. This is y equals 6 over x. And it would be super easy to check, like if you wanted to plug in your x value, like at my first point there I had -3 and -2 was the y value. If I did 6 divided by -3, I would get -2. So you can check these if you want to plug them back in to make sure. But if you're testing to see if it's an inverse variation, the x-coordinate times the y-coordinate will be the same for every single set of points for an inverse. If it's direct, you're going to divide the y-coordinate by the x-coordinate. So they're a little different. All right, so I'm just multiplying these two guys together. So -5 times 15. What, -75? Right? This would be -27. So I can tell you right then and there, this is not an inverse. Because they have to be the same for every single one. All right, if I come over, oh, I'm going to have to grab my calculator. Sorry, I should probably do it by hand, but I'm being lazy. Okay, so if I do -5 times 2.4, this is -12. -3 times 4 is -12. 4 times -3 is -12, and 8 times -1.5. You have to check all of them. If one of them is not like the others, then you're done. These are all equal to -12, though, if I multiply. So this would be y equals -12 over x. Technically, like I usually write it like this, but technically if you want to, you could put like the negative in front of the fraction. It wouldn't have to. I usually just attach it to the k value, but you can put the negative out in front if you want to. Does anybody have a question? Okay, so similar, but you got to remember which one you're working with. So if they give you an ordered pair, and it says this is an inverse variation, automatically I'm going to know that y equals k over x. So in this situation, if I need to find the constant of variation, it should be the x-coordinate times the y-coordinate. So if they give me a point, which they do here, the k value should just be the x-coordinate times the y-coordinate, which would be 10. Or if you want to actually plug it into the formula, do the y equals k over x. You could do it like that too. So the y-coordinate here would be 5. The x-coordinate would be 2, and we could solve it like that. It's your choice, however you want to do it. Same thing, the k value would be 10. But the general equation then would be y equals 10 over x. So that would be the first part. Then, if you have a problem like this, after you write the formula, they always tend to ask you, like, find me another value here. So it says find y when x is -20. So you literally just use your equation. So you'd have y equals 10 over -20, and if you can reduce it, that would be -1/2. So that's my secondary answer to that question. So if you want to remember, I'm just going to do this one here. If you have an inverse, the constant of variation should just be the x-coordinate, which is 1/4 times the y-coordinate, if they give me that point. So, you guys, anybody know 1/4 of 28? 7. So then my equation would be y equals 7 over x. That doesn't look like a 7. There we go. And then that secondary part of that question, this is a little tricky. This says find x when y is 2/5. So I'm going to plug in 2/5 for, I'm just using this right here, 2/5 for y, 7 over x. So this might be like, this one's going to be just like a little tiny proportion. So I would get 2x equals 35 divided by 2. And if you all want to leave that as a fraction, that is perfectly fine with me. Let me see what that is as a decimal. This is 17.5. Is anybody having a question? It's not terrible. You just got to have those two formulas. Okay, now, don't worry about the word problem. It's fine. We're just going to write a little variation for this. So, this says the distance traveled varies directly with the time of travel If the distance traveled is 75 miles in 1 hour, find the distance traveled in 90 minutes. Okay, so here's how I'm going to do this. You can use whatever variables you want. This is going to be, if it's direct, in the format y equals kx. That's the general format. Now, what I usually tend to do in a problem like this is use kind of variables based on what's in the problem. So I'm going to use d for distance here, and I'm going to use t for time. Okay, so in this general format, distance varies. The word varies, if you see that, turns into an equal sign. So I'm going to write d equals, distance varies. So distance equals directly, so I'm just going to put a k. You got to, don't forget to put the k. That's the biggest thing people forget to do. You got to put a k to represent your constant of variation. We don't know what it is yet, but we're going to figure it out. So k with the time of travel. So it would just be k multiplied by your time. That would be your general equation. Okay, now it's going to give you enough information to figure out k. So it says distance traveled is 75 miles in 1 hour. So the time would be 1. If I divide both sides by 1 there, that's not going to change anything. The constant of variation then would be 75. So my general formula for this would be the distance is 75 multiplied by my time. Then it's like those problems on the front. It's going to ask you some kind of a secondary question. It says find the distance traveled in 90 minutes. All right, so do I just plug in 90 for the time? Why not? Yes, okay. Here the time, so 1 hour, right? How many hours would 90 minutes be? 1.5, yeah. You have to use the same units. Most of the questions are not going to be tricky like that, but you have to use the same units. So the time was in hours, so 90 minutes is 1.5 hours. Okay, so then you're going to plug that in. So distance would then be 75 times 1.5. And I'm just going to multiply that real quick. I should probably know that, but I don't. I got 112.5. And your distance there is in miles, so it would be the same units. It's not terrible to do. Is anybody having a question? Okay, I'm going to scooch this up. Now, this one says the cost per person to rent a mountain cabin varies inversely to the number of people who share the rent. All right, so inverse relationship is y equals k over x, just in general. So in this particular one, let's do the C for cost and the number of people, like however you want to do this. I'm going to write N for number of people. All right, so my cost varies, so that's going to be an equal sign. Now, in inverse relationship, you got your constant of variation, which is going to be k, over whatever your other variable is here, which is going to be the number of people. So my constant of variation, I don't know, but I got to put a k in here so we can figure it out. Okay, it says if the cost is 216, so the 216 is going to go in for the cost per person when 5 people share. So this would be k over 5 people sharing. Then we're going to find the cost when 8 people share. So we're going to set this up like this. Just going to multiply by 5 real quick. So 216 times 5. Constant of variation here would be 1,080. So then it says, what's the cost? So we don't know the cost, but I do know the k value if 8 people go. So then we just substitute in 8 for the number of people. And then your cost per person is going to be 135. So the more people that go, the lower the cost will be. So just make sure it varies turns into an equal sign. Inverse is k over x, direct is k times x. Is anybody having a question at the moment? I am gonna erase some stuff off the board so I can put that up.